Now for the second half of section 4.1, we're going to look at elimination, and we're going to look at how to use it to solve systems of equations. On this slide, I've written the steps for how to solve by elimination, much like I did for graphing and for substitution. So for elimination, basically what you want to do is you want to multiply one or both of the equations by a constant, and what you want to do is force one of the variables to have the same coefficient, one positive, one negative. What that'll do is then we'll be able to add down and eliminate that variable, solve for the second one. And then you take that answer and substitute it in to the original problems and get your second variable. Let me go ahead and show you this as an example. I think it'll make much more sense. So when you want to solve by elimination, the first thing you want to do is make sure everything's lined up. You have to have x's above x's, y's above y's, and constants above constants. And what you're going to try to do is you're going to try to put the same number in front of either the x's or the y's. It doesn't matter which one. One positive, one negative, and that's going to cancel it. So for example, if I'm looking at my x's, I've got a positive 2 in the top. I could get a negative 2 in the bottom. If I look at my y's, a 5 and a 3, I could make both of those 15. So I could multiply the top by 3 and the bottom by 5. It doesn't matter which one, x's or y's, that you choose. I'm going to go ahead and choose x's just because I would be multiplying just the bottom of the equation. So if the top is a positive 2, I'm going to want to multiply the bottom by a negative 2, and that's going to force a negative 2 in front of that x. And once that negative 2 is forced in front of that x, we're going to be able to eliminate. So once I multiply the entire bottom equation by the negative 2, here's what I get. Now my top equation, I don't have to multiply by anything. It already has a positive 2y in front of it, so I don't need to do anything to this equation. So what I've done is I've forced the x's to have the same coefficient, but one positive, one negative. I didn't touch the y's. This one ended up changing just because I multiplied by negative 2, but I don't care that these are the same or not the same, as long as I have these the same. From there, what you do is you add down, and what's going to happen is you're going to eliminate one of the variables, hence the name elimination. So 2x plus a negative 2x, that's going to cancel, and that's what we wanted. 5 plus a negative 6 is a negative 1y. Negative 5 plus a negative 6 is a negative 11. Divide that negative 1 over, and I get y to be a positive 11. Now once again, just like you learned from last unit, 11 is only part of our answer. We need the x component as well. So what you're going to do in this case is you're going to take this 11 and you're actually going to plug it back into one of the two original equations. It doesn't matter which one. I always plug it into the top one. So instead of 5 times y, it's going to be 5 times 11 in this case, giving me 2x plus 55. I'm going to minus that 55 over, and then I'm going to divide by a 2, and that's going to get me x being a negative 30. So my answer is negative 3011, and that is elimination. I want to go ahead and look at a second equation. Let's look at these two. So if we look at our x's, x's are on top of x's, y's are on top of y's, and constants are on top of constants. It has to be set up appropriately. Now, we want the same number in front of the x's or the same number in front of the y's. It doesn't matter which. So for example, between the 5 and a 3, I could make both of those a 15. Between a 9 and a 3, I could make both of those a 9. So you choose whether you want to cancel x's or y's. I'm going to cancel y's in this case. I already have a negative 9 on the bottom. All I'm going to have to do is multiply by a positive 3 to get a positive 9 in the top, and that's going to give me what I want. So I'm going to multiply the top by a positive 3 here. And that's actually going to get me 9x plus 9y equals negative 45. The bottom we didn't have to multiply by. In some cases you will have to multiply both equations. In this one we didn't. And then we're ready to add straight down. So what I've done is I've created this. I've put a positive 9 in front of one and a negative 9 in front of the other. And that's going to allow me to eliminate those y's when I add down, which is what we want. It's called elimination for a reason. That gives me 14x equals negative 42, or x equals negative 4. Now, that's only half my answer. I still have to get my y. So what you're going to do is you're going to take this negative 4 and you're going to plug it into one of those two equations. It doesn't matter which. I'm going to plug it into the top one. So instead of 3 times x, it's 3 times negative 4. Once I add that 12 over, I get a negative 3, or y equals a negative 1, making my answer negative 4, negative 1. And we solved it by elimination.